Hello everyone, welcome back to another video. In this video I'm going to show you how I made this Droid base station. It's fairly large. It can hold my IG-11, so I've got its feet on here already. And I'm going to show you how I designed the interior with all the lights, the electronics, and the magnetic foot clamps for this guy. So stick around, let's get started. Alright, I'll show you what this Droid base station looks like in detail. So on the front I have a motion sensor. And what that does is it activates when someone comes close to the unit, and then there are some LEDs in the perimeter behind each of these baffles that scan 3 times in red, and then the whole unit fades in and out 3 different colors and then goes into multicolor mode. So they're all individually addressable LEDs. Not only does this activate the LEDs, but it activates 12 volts coming out of this jack here for IG-11 when he's standing on here. So I can just plug him directly into that. I've got these magnetic foot clamps. They're basically magnets that have a threading that's supposed to go onto a broom. And on the bottom of IG-11's feet are these round metal discs that I glued on. So all you have to do is stick that on there, one on the other side. And a little bit of adjustment you can have, but basically he's mounted in that manner. So in the original files, these were just recesses, but what I did is I punched them all the way through, and then these are transparent ABS printed diffusers. I've got 6 M4 bolts that hold this top bar on here, but basically it's pressure fit, so you don't really need to have them. And then the diffuser panel here is just a chopping block. They're just these thin sheet chopping blocks from the dollar store, and I glued them in from underneath. And then on to the back, the motion sensor has 2 potentiometers on it that adjust the time delay as well as the sensitivity. And what I did is I just extended the wires from them and put them on their own little circuit board at the back so that I could do that easily from behind here if I needed to. And I have an on and off switch and a 12 volt input. So that's basically my Droid base station. Did a little bit of weathering, it looked like rust. Top's made out of MDF, bottom's made out of MDF as well. Took 2 rolls of filament to print off the perimeter. So let's turn this on and see what it looks like when it's activated. Okay, I'll turn the switch on as if somebody's activated the motion sensor. You'll see it scans 3 times in red, and you can program that to do whatever you want it to do. And then it fades in and out 3 colors, green, red, and a blue. Same as the interior. And then it goes into a multicolored mode for now until I finalize what the color scheme is going to be like. So that's just in test mode for now, but it seems to be working pretty good. I'll shut the light off so you can see some more vibrant colors. And the camera, I don't know if it's picking up everything, but in real life it looks pretty good. Yeah, and that'll stay on until the delay has run through, and then it'll shut off, and then it'll be reactivated when someone walks up to it. Here's my Fusion files that I put together to create this large version of the base station. So I took the original files from Droid Division and I enlarged them by 1.8 times. I did a couple other things as well. I took the top, the grill, and I put in a recess here of 6 millimeters depth so that I could put in a 1/4 inch MDF. And at the bottom, there's the same kind of recess there for an MDF bottom. And I cut the bottom and the top out of 1/4 inch MDF on my CNC, but you could also cut that on a jigsaw if you needed to. The other thing I modeled in were these holes for some heat inserts. They're a little close to the edge here, but next time I would have moved them over. You don't really need these mounting holes for the grill. It seems to fit pretty good just by pressure, but I've got them in there anyways, and they seem to work out. I also took the little inserts that were on the side. They just went in a little bit, but what I did on mine is I had them go directly through the entire perimeter so that the light can shine from the inside out. And what I did is let me just show you the pixel supports. I made these little supports to glue in, and I have a NeoPixel on the back of each one of these, so there's 32 of them, so that they shoot outwards. And there is a baffle, there's like a translucent covering that goes on before this, so it's not open just to the air out there. It's got a diffuser as well. So that's the NeoPixel supports there. Let's take a look at, well, there's a diffuser right there, you can see. That's in yellow, but I've got it actually printed in ABS transparent, and they just pop into there. I made these bases. They're printed in PETG. They have a threading on them because basically what I did is I'm screwing on a magnet, and these magnets are ones you can buy at hardware stores. They have a threading on them for a broom handle, and they look like this. You can see. So the magnet's on the top, and they can screw in so they can move up and down and left and right. So that's going to clamp my feet for IG11 onto there. And there's a bit of a recess right here, you can see. That compensates for the thickness, the 6 mil thickness of the MDF, so that this part here is all flush with the bottom, and this tucks into a little cutaway at the top, so that there's support for the weight of this droid. And I just glued these guys into the base. Okay, there's my right foot and my left foot, just so you can see. That's just a cutaway view of them, how they're going to be attached. So I'll just take those off for now. The bottom is just MDF, and my grill looks like that. So you can see here that the higher portions just tuck into the inside, so it self-levels, or actually self-centers this foot support on both sides, and then the magnet can go up and down, and then your feet are going to be just magnetically attached to that. So that's basically what it looks like. The other thing I have on here, let me just take off these feet here, is this hole here in the front. That's for my motion sensor. So the PIR motion sensor just gets pushed into there, and on the back I've got a cutout for a little mini circuit that has the 2 potentiometers from the motion sensor, so I can adjust the time delay and the sensitivity. This is where my rocker switch goes, and that's where the input 12 volts goes. So glued that all together, and it took me 2 rolls of filament to do the perimeter. So that's kind of the files that I put together for this. Let's make this grill first. I got it on the CNC. It's cutting out all of the contours and the perimeter, pocketing out all the holes, and it's took about maybe 20 minutes or so for it to do that. Here it's drilling the mounting holes for the M4 bolts. I like to seal all my MDF with some sanding sealer. The top of this was already had a painted surface from the store, and I was just doing the inside edges because I'll be spray painting this. So I'm using a gloss black first because I'm going to cover this in a metallic aluminum. So just I think a gloss black will help the aluminum to shine a little bit better. So here I am, just giving this a coat of nice gloss black. I use this Rust-Oleum metallic, There's a lot of these areas you won't even see, so I'm just giving this a coating of some shiny metallic, which I'm going to add some rust texture to once that's all dry. Here I'm dabbing on a mixture of some baking soda, some brown, orange, yellow, and black acrylic paint. Just dabbing it on to give a rust texture. I found that going back over it a few layers at a time with some different colors, like some highlights of yellow and orange, help create the rust effect. Now 3D printing the perimeter, I used PLA actually, and that's just a 7% infill with a tree supports. Once it's all done, I put some Bondo on the rough textures and glued it all together, and then started sanding it down and joining it together so that I could sand all the seams so that hopefully they'll be invisible once all the Bondo and glue is dried up. I coated it with some primer, some sandable primer, gave it a nice thick coat, and then proceeded to do a wet sanding with, I think, 800 grit wet dry sandpaper. This will hopefully give it a nice shiny surface, smooth surface for my coat of black and then aluminum. Here's the gloss black going over top of the perimeter once all the water had dried. Give it a nice coat. I found that gloss black Rust-Oleum really runs easily, so I made a few mistakes by adding the coat too thick. So you have to be careful of that. And then I covered it with the same Rust-Oleum metallic. Now comes the part where we add some masking fluid. So everywhere you would like to keep the metallic surface, you're going to put masking fluid on. This stuff dries very quickly, so you have to work fast. I think next time I might thicken it up a little bit before adding it on, but it seemed to do the job. I tried to put it in areas where I thought the paint would wear off and show the metal surface underneath. Next comes the blue base. So I wanted this perimeter to look like it was originally painted blue over top of metal. So gave it a nice coating of blue. And then once that was dry, I can use my finger and rub off all of the masking fluid to show the metal underneath. I thought it'd be good to weather it a little bit more, and I used an old rag and dabbed some black splotches all over the grill and the perimeter just to give it a look, more of a dirty look. It really helped. I think that really added to the effect. These are the NeoPixels I use. They come in a sheet. You just break them off and solder them up any way you want. This is the back, so they've got a common ground, common power, and a data line in and out. And I also modeled out these holders that go right behind all of the recesses so that the NeoPixel just gets glued into these holes to form the first 32 LEDs in my string. There's the diffusers that I made out of ABS transparent, and they pop into all of the slots around the perimeter. So that's what it looks like from the inside. So you can see my LED strip that I bought, and it ties into the NeoPixel strip that I made. here I am soldering a NeoPixel, so you can see it's best to just put it in a vise, add a little bit of solder on each of the tabs, and then I used servo wire, and unfortunately the servo wire colors didn't quite match. The black is okay, and I had to use the data line for the red, and the ground is white. So I made sure I kept track of that, and then at the very last pixel I just swapped the wires so that they're the right color code. There's a 3D printed housing I made for all of the electronic parts, and there they are mounted in. Okay, let's take a look at the circuit that controls this Droid base station. First of all, this is the motion sensor that I used. It's a fairly common one. It's got a time delay here and a sensitivity, and it is called the HC-SR501. So it's very common. This is the underside of it, and it's got a couple potentiometers here, so that's these ones here. And basically what I did is I unsoldered them from here and ran 6 wires, from 3 on each, to a mini control board on the back of the base station, so I can control the time delay and the sensitivity remotely, or easier anyways than trying to get inside of the front of the station. So it takes 4.5 to 20 volts, so I'll be putting 12 volts into there to power this up. The ground is on the other side, and the output is right in the center. It also has this little switch selectable unit right here, so if you have the jumper on this position, it's a no repeat. So that means that the Droid, the motion sensor will activate once, and then after the time delay it'll shut off, and then when there's more motion it'll reactivate. Or you can have it on repeat, so that as long as there's motion in front of it, it will keep re-triggering and stay activated. So that's the motion sensor anyways. So let's take a look at the circuit. So I've got 2 of these jacks here where you'll be plugging power into this end. This is the back of the station, and this is on top of the grill, which power will come out of to go to my IG-11. I have a rocker switch that's attached to this as well. And then here is my voltage regulator. So originally I had a smaller one here that was good for up to 3 amps. But I found that with the LEDs that I'm using, there's quite a few. So there's about 182. So it's going to draw a lot of current if all of the LEDs actually turn white, because that's going to be powering up maximum amount of LEDs on that strip. So what I did is I just used a bigger voltage regulator. This is good for up to 5 amps. And I noticed that when I powered it to my power supply, it was drawing at about 1.5 amps. So this still heats up, but it can handle it a lot better. And I've got a 5 volt coming out. That's what it's suggested for. There's my motion sensor, and I'm using this. This is a shield. It's a terminal shield for a Nano. So the Nano just plugs into that. So I had a bunch of these, so I thought I'd try it out. And then 2 relays. These relays operate off of 5 volts, so I have to use the 5 volts from here. And then my NeoPixel strip. So basically, I used individual NeoPixels as I've shown in my video, and I made a strand of 32 of them to go around the perimeter, and the last NeoPixel in that strand gets hooked up to the first one in the strip that I bought, and this is just one off of Amazon, and it's a 5 volt strip as well. So here's our power coming in, it's 12 volts, and it goes to the regulator, and it goes to the IR motion sensor, and it also goes to the relay, which is going to power up. When it's activated, it's going to give power to the Nano, which will have the sketch on to operate the NeoPixels, as well as power up my IG-11 with 12 volts of power. The output is 5 volts, so everything in orange here is 5 volts. So that's going to the relay, the second relay, which when this is activated, it will power up my NeoPixel strip, so all the LEDs. And it also needs 5 volts power, so I'm tapping off from there. and the ground hooks up to the rocker switch, which goes into the input there, and then it grounds my nano as well. The nano is also grounded, or the whole ground negative supply goes to the NeoPixels. And the NeoPixels, best practice, you'll need a 1000 microfarad capacitor for spikes, and it's just hooked up directly like that. And then my ground is also shared to IG11. The ground is also connected to the relays, so everything has a common ground. And then my output from my IR sensor goes to a 220 ohm resistor, a little transistor, because I found that the output is not enough current to actually power up both of these at the same time. So I am grabbing some extra current through a transistor and hooking it up that way. So that works pretty well. So you've got your output triggering both relays there. And then I've got 5 volts. Oh, sorry, this is my output for driving the NeoPixels, and it's hooked up to a 330 ohm resistor, and that goes directly into my NeoPixel or LED strip. So that's the wiring diagram, and it seems to be working pretty good. Thanks for joining me in another video, everyone. My next step is to finish IG11 and get him mounted on his new stand. God bless you, and we'll see you real soon.